Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video now we will discuss information management in detail. In the previous video we have already studied about the three areas in which operating system divided services. So they are information management, process management and memory management. In this video we will have a look on information management in detail. Concept related to information management. Now as I said, information management is basically deals with whom? File. So whenever we create a file, whenever we read a file, whenever we write into a file, whenever we create a directory, all these system calls, they comes under the category of what? Information management. So we have to keep it in our mind that information management is something which is related to whom? File. So let us have a look on information management. Number one is a file system. Now what is a file? As I said, file is a collection of what? Information, and that information can be numeric, it can be alphabetic, or it can be alphanumeric. So file system allows user to define a files or create a directories and allocate and delocate a space to each file. Files are mapped by operating system on physical devices. So as I said, a file is a collection of what? Information, and it can contain a program and data, and it can be a numeric, alphabetic or alphanumeric, and each file has a extension. For an example, if you are creating a HTML file, we have already studied HTML. So in that case we have studied key to create a HTML file we give an extension as .html. If you are creating a document file, then we give an extension as .doc. If you are creating a text file, then the extension will be .txt. So what they have to say is each file has a name and each file has what? Its extension. Now there are two types of file system. Number one is called as tab-based system and number two is called as disk-based system. Now tab-based system has been replaced by disk-based system. Now no one uses tab-based system. In early days we used to use what? Tab-based system. Now what was tab-based system? In the tab-based system there was a physical reel. So the problem with the physical reel was it was very long and your data was small. So more number of files we used to store on that physical reel. So finding a particular file from the physical reel was a time consuming. So this problem was replaced by the disk based system. So what they have to say about the tab based system, we'll have a look on it. Early file systems were tab based, and as I said, the tab based means what? It was having physical reels. So physical tape reels are large but most of the files are small. So more number of files we used to store on a one tape. A directory is added to a tape which lists the name and location of file on the tape, but the problem was finding a file was very time consuming. So this was replaced by disk based system. In the disk based system we have a tracks and a sectors. So your disk is basically divided into track, and tracks are further divided into a sector. Each sector contains a unit of information. So let us see what they have to say. The problem with the tab based are resolved with the disk based. In a disk based system, a disk is used and disks are divided into tracks. Your tracks are further divided into sectors, and we say sector is what? A smallest unit of information. A sector vary from 32 bytes to 4096 bytes. So this is basically a disk based system. Next, we will see what is blocking. It is a unit of data which operating system defines for the sake of convenience. From hardware point of view, disk consists of sector, but from the point of view of OS, disk consists of what? Blocks, and each block has one or more sector. So what we have studied, disk contains what? Tracks, and tracks contains what? Sector. So from the hardware point of view, a disk consists of sector, but from the point of view of operating system, your disk consists of what? Block, and each block has one or more sectors into it. So file is considered to be a sequence of block, and all basic input output functions operates in terms of block. Next we will see what are the file operations. Now see, there are several file operations like creating a file, writing a file, reading a file, rewinding a file and deleting a file. Now we will discuss each operation in detail. Number one is creating a file. Now to create a file, first we see whether specified space is available for that file is check. So obviously when we create a file, as we discussed in the beginning of this topic only, when we create a file, first we need to see whether specified amount of space is available or not to create a file. If the space is available, then only operating system allows us to create a file. So for creating a file, first specified space is available or not, that is check, and if it is available, then entry for the new file is made. Number 2, writing a file. For writing a file, there is a command in which name of the file is given. Then operating system searches for that file in a directory and then writes to it. Suppose if I want to write into a ABC file, then first I will search whether ABC file is available on the disk or not. If the ABC file is available on the disk, then only I can write into the file. So first operating system has to search whether ABC file is available or not. Next is reading a file. Again, to read a file, we need to do the same thing. Suppose if I want to read a ABC file, then again I have to see whether ABC file is present in the disk or not. Then operating system will search for the ABC file. If the ABC file is present in the disk, then we can read the file. Number 4 is rewinding a file. Again, for rewinding a file, the directory is search for appropriate entry. So again I have to see whether ABC file is there on the disk or not. If it is there, then my file is reset to the beginning of the file. So what is basically rewinding a file? When we start from the beginning, I called it as what? Rewinding. Next is deleting a file. Again, suppose if I want to delete a ABC file, then again I need to search whether ABC file is present in the disk or not. If it is present in the disk, then I can do a delete operation. So students, in this thing you have understood that searching operation we are doing repeatedly. So for this, what operating system does, operating system makes a list of files which are recently used. Now suppose, as in the previous example, I was constantly doing the operations on what? ABC file. So instead of searching ABC file on full directory, operating system will create one list. In that list, he will make sure that all my constantly used files are open. In this case, operating system don't have to search for the search in the entire directory. Instead of searching for the entire directory, operating system will search that ABC file into the list of open files. So it will take a less time to search that particular file. Next is access method. Now there are two types of access method. Number 1 is called as sequential access and number 2 is called as direct access. Now see what they have to say about the access method. File stores information, and when it is used, this information must be accessed and read into a computer memory. So as I said, there are two ways in which we can access the file. You can access your file directly or you can access your file sequentially. Now sequential method is very simple. If you are using a sequential method, then in that method you have to access the file in sequential way. As we have studied, file consists of what? File is a sequence of blocks. So now suppose if my file is divided into 10 blocks. So I have a block from starting from number 1 to number 10, and if I am using a sequential access method, then in that case, suppose if I want to access a block number 5, then I have to start accessing a file from block number 1, then I will access block number 2, then block number 3, then block number 4, and then block number 5. So this type of method is called as sequential access method. Now the problem with the sequential access method is, to access block number 10, you have to start with the block number 1. So we can go for the another method, and that method is called as direct access. In the direct access method, you don't have to go sequentially. Now suppose if I am looking for a block number 2, then I don't have to start from block number 1. I can directly jump onto block number 2. Suppose if I am looking onto a block number 15, then I don't have to go from block number 1 to block number 14. I don't have to do that. I can directly jump from block number 2 to block number 15. So this type of method is called as direct access method. Now see, a file is a view as a sequence of blocks. This we have already discussed. A file is a consist of what? Sequence of block. And in this method, any block can be read or written. So we don't have to go in the sequential. We can read a block 14, then for 53, then we can write block 9. Anyway, there are no restriction of order of reading and writing. Yes, there is a restriction in what? Sequential access method. In the sequential access method, you have to go sequentially, but in the file access method, you can jump onto any block as you wish. Next is allocation method. The direct access to a nature of disk allows us to store many files on a same disk. So there are three major methods of allocating a disk space. Number one is called as contiguous, number two is called as link, and number three is called as index. So we will see each allocation method in a detail. So let us start with the contiguous. Before contiguous, there is one topic called as free space management. It is necessary to reuse a space from deleted files for a new file. See, as I said, your memory is what? Limited. So you have to use your memory in very efficient way. So in that case, you should not waste your memory. You have to reuse the memory. So to keep a track of free disk space, the file system maintains a free space list. To create a file, it search free space list for required amount of space and allocate it to a new file. So when we create a file, first it will search for what? Free space list. Means first it will see whether the specified amount of space is available or not to create a file. If it is available, then it will allocate a it will allocate that space to a file. This space is then removed from the free space list. Obviously, initially, suppose if I was having a 50 MBs with me, and suppose I have created a file of 10 MB, then that 10 MBs will get deleted from the free space list, and now your free space list is updated. Now how much memory you are left with? You are left with now 40 MBs memory. So this is called as what? Free space management. This space is then removed from the free space. The free space list is implemented as a bit map. So each block is represented by 1 bit. So if the block is free, your bit is 0. If your block is not free, if your block is allocated, then your bit is what? 1. So this is called as what? Free space management. Now let us come back to the topic contiguous allocation. What is contiguous allocation? In the contiguous allocation, we allocate a space in a contiguous way. It means address will get allocated in a contiguous way. So contiguous allocation method requires each file to occupy a set of contiguous address. Contiguous address means, suppose if my first block is stored on 1001, then obviously my next block will get stored on 1002. Then my next block will get stored on 1003. So this type is called as what? Contiguous allocation. So suppose if you are allocating a first block in 1001 and if you are allocating a second block in 1005, then this is not allowed. You have to allocate a space in a contiguous way, like in array. In array, what we do? Array stores the data in what? Contiguous way. So same thing is applied over here. Contiguous allocation of file is defined by disk address of the first block and its length. So how we define the address? By the disk address of first block and its length. So if the block is n block long, then it starts at location B. Suppose if your block is n block long and if it starts at location B, then it will occupy B, then my next will be B plus 1, then my next will be B plus 2, ... it will be B plus n minus 1. So in this way your contiguous allocation method works. Next thing is dynamic storage allocation. Now next thing is dynamic storage allocation. A disk space is a collection of free and used segment. Each segment is a contiguous set of disk block. An unallocated segment is called as a whole. A dynamic storage allocation problem is how to satisfy a request of size from a list of free whole. So there are three techniques: first fit, best fit, and worst fit are used. Now what is dynamic storage allocation? What they are saying, a disk space is a collection of what? Free and used segment. Obviously in the disk space we have some segments which are free, we have some segments which are what? Allocated. Now those are the free segments. I called it as what? Holes. Okay, so we have three techniques basically in this: first fit, best fit, and worst fit. We will see each technique in detail. What is first fit? In the first fit, it allocates the first hole that is big enough. So searching can be started either at the beginning of the hole or where the previous first fit ended, and we can stop the searching as soon as we find the large enough hole. Next is called as best fit. In the best fit, it allocates the smallest hole which is big enough. So we must search the entire list unless the list is kept order by size. Next is worst fit. In the worst fit, it allocates what? It allocates the largest hole. Now we will see all these three techniques with the help of example. Now let us see first fit, best fit, and worst fit techniques with the help of example. Now suppose if I have these are the available blocks which I have. In the first fit, what will happen? Suppose if I get a request of size of 3 MB. Now in the first fit, it will allocate a first hole which is big enough. Now see, my request is of 3 MB. So if I'll start from the beginning of the list, then I will get here what? 10 MB. So 10 MB is a first hole which is big enough to satisfy what? 3 MBs. So 3 MBs will get allocated in this 10 MBs. So here there will be a wastage of what? 7 MBs. In the best fit, it will allocate a smallest hole which is big enough. Now if you'll go through the list, then which is the smallest hole which is big enough to satisfy the request? Yes, 5 MB. So this 3 MBs will get allocated in this 5 MB. So again there will be a wastage of what? 2 MBs. In the worst fit, it will allocate the largest hole which is big enough. Now which is the largest hole? 30 MB is the largest hole. So it will occupy 3 MBs into 30 MB. So here there will be a wastage of what? 27 MB. So if you will see, in everywhere there is a wastage of memory. But as compared to a best and first fit, in the worst fit there is a large amount of what? Memory wastage. Now this wastage of memory is called as what? Fragmentation. Now there are two types of fragmentation. Number one is called as internal fragmentation and number two is called as external fragmentation. We will see what is fragmentation in detail in the concept of what? Memory management. So I hope you have understood what is the first, best and worst fit technique with an example. In the first fit, what we do? We allocate a first hole which is big enough. In the best fit, we allocate a small hole which is big enough. And in the worst fit, we allocate a largest hole which is big enough to satisfy the request. So these are the three techniques which we use. And you can say worst fit technique is a worst technique because it wastes a more memory as compared to whom? First and best fit. Now the next technique is called as link allocation. Now see, this is the list of disk block which I have. So my disk block starts from disk number 1, 2, 3, 4, 5, 6, 7, 8 and so on, and it ends at 24. Now in the link allocation, I will be having a starting address of a list block and ending address of a list block. So suppose if the starting address is 9, then I have to start from block number 9. Then from block number 9, I will search for a next entry. Now suppose if the next entry is at block number 7, then I will directly link to a block number 7. Now suppose if the next block is at the block number 12, then I will link to the block number 12. Now suppose if the next block is block number 15, then I will link to a block number 15. And if the last block is a 21, then I will link here 21. So this is called as what? Link allocation, where your file is a linked list of disk block. So if you'll see here, my file is a linked list of disk block starting from block number 9 to block number 21. This is somewhat related to whom? Linked list. In the linked list also we used to do that only. We used to have a file entry of the first block, and then we were having the address of next block, and we used to link the first block with the address of next block. So in the same way here also we are linking the address of first block with the address of next block and so on. So this is called as what? Link allocation. Now let us see link allocation in a detail. So in link allocation, each file is a linked list of disk block, and this disk block may be scattered anywhere on the disk. So as we saw example, we were having around 24 blocks, and those 24 blocks were scattered on the disk. A directory entry content pointed to the first and last block of the disk. So we saw we were having a first block, and that first block was pointing to block number 9, and my last block was pointing to block number 21. So what I did, I started from block number 9 and then I ended at where? Block number 21. So when we create a file, each directory entry has pointer to the first block of the file, and this pointer is initialized to nil. So when we create a file, basically what happens, each directory entry points to what? First block of the file, and that block is initially it is initially nil. So a write to file removes the free block from the free space list and writes to it. So write to file, what it will do, I will remove the block number 9 and then I will start writing into a block number 9. This new block is then linked to the end of the file. For an example, suppose I started from the block number 9, then my next block was block number 7. So my block number 7 will get attached to whom? Block number number 9. I mean, it will get attached to end of the block number 9. Then after block number 7, I was having what? Block number 12. So block number 12 will get attached to block number 7. So in this way, my link allocation will happen, or in this way my link allocation will work. So starting from block number 9, next block I was having was block number 7, then next block I was having was block number 12, and so on. This new block is then linked to end of the file, and to read a file we simply reads block by following pointers from block to block. So in this way we have to, suppose if I want to read a block number 12, then I have to start from block number 9, then I will go to the block number 7, and then I will go to the block number 12. So here I get two advantage. Any block can be used to satisfy a request. As you have seen, we were not doing anything in contiguous way. Like I started with the block number 9, and then I jump back onto a block number 7, then I jump back again onto a block number 12. So I used any block to satisfy a request, and there is no need to declare the size of file when it is created. Now what is the disadvantage here? We get to read block number 12, I started with block number 9, then I jump on to block number 7, and then I jump on to block number 12. So major problem is that a link allocation can be used effectively for what? Sequential method. So this was about the link allocation. Now the next method we have, that is index allocation. In index allocation, all pointers are brought together into a one location called index block. So here you will have one block. In that block, all your pointers will be, all your pointers will get stored into that block, and that block is called as what? Index block. So it means your pointers are not scattered now. Your pointers are there in the one block, and that block is called as what? Index block. So each file has its own index block. So the ith entry points to the ith block of the file. To read ith block, we use the pointer in the ith block entry, and when we create file is created, all pointers in the index block are set to nil. So basically when file is created, all pointers in the index block are set to a nil. Now we will see what is index block with the help of example, then you will understand it more clearly. Now see, this is an example of index allocation. Now suppose if these are my disk block, and this is block number 16, I called it as index block. Now in this index block, I have the pointers to all block, and those pointers are 9, 7, 12 and 21. So same example I have taken, which I had taken for in link allocation. Now in the link allocation, what I did, I started from block number 9, then I jump onto block number 7, then I jump onto block number 12, and then I ended at block number 21. But in this case, if you will see I have an index blocks, that is 16. So I called it as what? Index block. And in this index blocks, I have the pointers to all other blocks. So when basically I will point to block number 9, I will jump from this index block to block number 9. Then when next block comes, block number 7, again from the index block, I will jump to block number 7. Now next block number 12, so from index block, I will point to block number 12. And the last is what? Block number 21. So if you compare this method with the link allocation, you can see in this block in this method I can access any block. So I don't have to go in sequential way. Suppose if I want to access block number 7, then I directly can jump onto a block number 7. Why so? Because here my two blocks are not interconnected to each other. All my entries are done from where? Index block. So this is called as what? Index allocation. I hope you have understood this topic of information management. Now in the next video, we will talk about process management. Thanks for watching this video.